All right. Hi, everyone. Welcome back. Hope you had a good lunch break. Can one of you just please unmute and say something so I can make sure my audio is coming through? Because I remember I was having trouble.
Hello.
Perfect.
Yep.
Thank you guys so much. Wonderful. How was the morning's lecture? Interesting. Very good. Okay. I know you guys had some time to think about like features that you might need for a hobby app as well. Something for your own, like if you were to create a website based on what you learned about features, in the lab after this, you'll get a chance to actually, think about how a website like that is going to be laid out. So I think that's going to be fun. But before we get to that, nice, you're looking forward to work with UX UI. That's awesome. For this lecture here today, well, not today, but the second half of today, what I'm going to be focusing on is another area of the development cycle that is very important for all developers to know. And as with every single area that we're introducing you guys to, it's a whole sub area of itself, like in its own right. And so, if you are interested, as we go through this, if you are interested in this area of work, it's something for you to think about going forward as well. So what area of work am I talking about? I'm going to be talking about the mostly focusing on giving you an understanding of what code is all about, what, like, not necessarily the coding process itself, but what is code to begin with, where does your role as a programmer come in, and at the same time, what is a bug? We'll get to that. And again, it's a whole career path as well if you are looking to if you're interested in finding out what problems are, figuring out solutions, QA is quality assurance is a field of itself. So to start us off, I'd like some guesses for both questions here. What is code and what is a bug? Because the word bug, it's like I think about actual bugs and I don't like bugs. So what do you guys think in the context of being a programmer?
Is it like code is the instructions and then the bug is the I guess possible errors or like I don't know what the right term is, but basically like problems, I guess, with the code.
Okay, yep. So code is also seeing some suggestions in the chat as well, plus your answer. Yes, so code is the instructions that we are providing. It's like our way of communicating with the computer. And then bugs, here I see it's an error. You also mentioned errors. I see mistake here. When the code is not working as per the instructions, unintended results from what you're trying to do. Code is a block of instructions. So I'm seeing a lot of, code is instructions. Now, how does the code you write turn into machines understanding it? That's really what we'll talk about today, because I remember, I think it was, I don't remember which lecture it was, but in a few lectures ago, the question was asked about, how do computers communicate? And a lot of the answers that you guys were giving was, oh, they understand things in zeros and ones. But then the question is, what does that actually mean, right? So, when I think about zeros and ones, I think about one of my favorite shows, which was Futurama. And, there's this scene here where with the robot guy, I don't know if the audio is going to come through, but does audio come through? Like when I play that?
No, so far I don't think we
Okay,
hear
let
anything.
me try this again, because it's a, oh, actually, wait, there's nothing wrong with this. I need to change my screen share option. Can't hear Bender. If you know Bender, you would know when you hear him. Share sound. Oh, okay, there we go. Let me try that again. Okay. So this time around, let me know if you can hear him. Did that? Yes, okay, beautiful. Okay, so I'm just gonna play this little clip here.
0101100101. What does it mean?
It's just gibberish. 101001101010. Ah!
So clearly he understood something that none of the others did. And out of curiosity, I actually looked up what that means, what this little second code that he read here, what it means. And when I looked it up, what came up was basically a big question mark, which it's pretty like apt response for a question mark. So the computers, yes, they do understand things in zeros and ones, but somehow what we as humans are providing as either code or images, text, nowadays we can write to ChatGPT in like regular language, and like it's coming back and spitting things out as if it's like understanding us actually. But at the end of the day, everything's a computer in some way, and like there is some kind of translation happening in between what we're saying or what we're understanding and what the machines are. No. Okay, so what are the zeros and ones actually? So at the core, the computers are these little silicon-based devices. They have transistors in there, which is like an electric component. And the way they work is by sending signals. They're just electric signals across the circuit. And I don't want to get into like the whole like the electric I guess side of things, but you can think about these transistors as switches. So in this little GIF here, we've got, or GIF, or however you pronounce it, we've got a switch that when the switch closes, we get the light turning on, and when it's open, the light is off, right? So very similar to that, within these circuit boards, there's like thousands of these little chips. And what happens is when a set of these transistors allows current to go through, the CPU, which is the brain of the computer, gets that as a signal, and it uses that as information. Now, between, again, what we provide as humans and what gets translated into these signals of zeros and ones, there is a translation code. So for things like language, the code is typically related to like a number of these zeros and ones being on at the same time. So each of these zeros and ones, these little transistors, are going to represent what's called a bit. Now, you guys also in the chat, I remember one of the days, there was a lot of like suggestions about bits and bytes. What are bytes? So each of these little pieces of data, right? It's on or off. That is a piece of data there. That is a bit. And when you put 8 of these bits together, that's what we consider a byte. Okay, so the reason why that's important is because the computers take these bytes as information and translate them out between human and computer language. What does that mean? This little like this little I don't know, this is a cartoon here. This guy here is like, are you ill? This one says, no, just feeling a bit off. And if you look at his numbers, one of his bits are off. So I just did the thing where you explain a joke, but it's just meant to portray that when you change one of the bits, you get a different representation on the machine side. Okay, and each of these bytes, when you put them together, with other bytes, the computer can take a bunch of these bytes at once and interpret that, like all of these zeros and ones all together, as a representation of, I guess, human language in some way. So here's another one where if you put together 8 of these bytes, so these are 8 bits, and then you put 8 of those together, you get what's called a double, which is just a really, really long number. And depending on, which ones are switched on and which ones are switched off, they're going to represent different numbers. So I don't want to get too far into the details, but just as an example, if you have the number, the number 1, that would probably be represented by everything being set to 0 except for the last guy's 1. If you had the number, 4, well, the conversions are interesting because our number 4 gets converted out into a binary version. So binary of this, and you don't need to know the conversions, but binary of this looks like 100. So that would look like if you were trying to represent 4 in a double, you would have everything set to 0 except for 100 at the end. Okay, so similar to that, you can pick any random number, find out what the conversion is, and then, when the computer looks at all of those numbers, it knows what that number represents. And you can already tell at some point there's going to be a maximum number that you can have. And there are ways to, accommodate or get around that. But, if you think about this, if all of these numbers are set to 1, so everything is 1, 1, 1, 1, 1, all the way to the end, and you have this giant number, and then you want to add 1 to it, well, there's no space to add another 1 in there. And so that can lead to an overflow, which we can talk about, sometime in the future. It's not something super important. What's important here is that everything has a conversion, and every single piece of data that you ever create, text, documents, images, videos, they're always going to be sized in terms of these bytes. And you may have heard the terms of kilobytes, megabytes, gigabytes, terabytes, onwards, right? So every single piece of data that you ever create or interact with is being held in these sets of numbers. Now you might ask the question of, well, how does that actually work? So let's take a quick look at an example of conversions from letters to bytes. Okay, so here we've got 4, 2, 2, 2, yeah. That so yes, in the chat here with Abdul Hadi has put 100 means 4 because each of these spots represent a 2. So yes, thank you so much for that. So in the data conversions from letters to binary, we can skip over ASCII code for now. We'll come back to that later. But for this, if we're looking at, let's say, the letter H, because that's what my name starts with, then in binary, the letter H is going to be represented by this. So you can see here, this is a byte because this is 4 and this is 4. So there's 8 bits here. And all of these bits for all these different letters are unique, right? So, I can go to Z because my last name starts with Z. Let's go here. And I can see that that's another, a different set of bytes, right? Like the bits that are on around. And if I put these together, if I put this set and this set after each other, well, that's probably going to represent HZ, right? My initials. But again, these are the small letters, and then the capital letters are represented differently as well. So you can see over here, H and Z, they're represented differently. And what you'll also notice is that the first number for all of these are still 0, which hints at there's a lot more characters and objects that can be represented with these bytes, because we haven't run out of spots. And the way these get filled is they start filling on the right hand side. So just as an example, going from here to A to B, because we need to, that's just one letter off, right? So what we would do here is we would say, well, this is my A, and if I want to add on 1 to A, well, there's no space for 1 here. There's no 0. There's a 1 already. So we're going to shove that 1 over, and that's going to be the action we'll take to move to the next step. And then going from B to C, we're going to say, well, we need to add 1 to B. And then at this point, we're like, oh, there's space. There's a 0. Let me just stick the 1 in there. And then when trying to go from C to D, we say, okay, well, I need to add a 1, but there's no space here and there's no space there. So we're just going to shove the 1s over by 1 and set these to 0. So every time you do a shoving operation in a way, you're basically counting up. So this here is D, so on and so forth. So again, you don't need to know like off the top of your head the details, but to give you a sense of how that conversion is going on. So your text documents, if you write even this data conversion, for the computer, it is being converted and stored on like in memory, for example, as bits, as bytes for each of these letters. So that's going to be stored. And then after that, this is going to be stored. And then a small t is going to be stored. And then another A is going to be stored, so on and so forth, until you have this giant string of like numbers. And so when those numbers get, run through the machine and it's trying to create this, visual document for us, it's going to use that information to provide that text. There's a question here. These numbers are created automatically, or do we need to do that? They are fixed. Whoever, I guess, came up with the machine representation of letters, it's like a standard that's set. You don't need to worry about that. Yeah. And typically in our code, when we're interacting with letters in some way, what we'll use to represent them is these ASCII codes, which again, we'll come back to later. So this is good for letters. This hopefully makes a little bit of sense, kind of going from these letters. You can take them one character at a time and convert that. But what about pictures, right? Pictures don't have letters like that. And we have, billions of different pictures. And, every day humans are creating so many more pictures. There's no way that we can have a standardized thing like this, right? Or can we? So pictures, what's interesting about pictures is that they are, even though they look like a single block of like, a picture that we see, they're actually made up of these tiny little boxes. And I won't bother filling up the whole thing, but tiny little boxes, and each box is called a pixel. Whoops. A pixel. So if you've ever, downloaded a picture and then tried to like stretch it across your screen, and then it started to look really not nice anymore, because when you stretch it up, like it gets what's called pixelated. That's an example of having like the pixels used to represent that image were too small. And so when you're trying to stretch it out to be a larger picture, there's more pixels needed for the same color, and then you end up with a not pretty picture. Alexander, I see you unmuted. Do you have a question? I don't hear you. If you want to use the chat, please feel free to do that. So just as an example of these pixels, I've got a little picture here. And of course, this is like very maximized. Our pixels on our computer screens are like very, very small. Like, I don't even know if this is a single pixel. Oh, yes, I can hear you. Sorry? Oh. Okay, I'm assuming that was just a mistaken unmute. If you did have a question, please let me know. So in this case, if we had, not great pixel resolution, then we would have a picture kind of like this, where it's a little smiley face there, right? And to the computer, what it can do then is it can represent every blank spot as a 0 to say, well, there's nothing in here, right? It can say, well, 0, 0, 0, sure. There's nothing here. And then when there is something there, when there is, text or some drawing, here there's the eyes and the mouth, it's going to represent those boxes with ones. So that's what we see here on the right-hand side. Okay, so in the computer, like on the computer side, what it's seeing then is all it needs to know is, this is eight numbers, or not even numbers, but pixels. As long as it knows that this picture is made up of 8 pixels up and 8 pixels down, then what it can do, you have a question?
Yes. I would like to know. Oh, I think it's. Let me lower the volume. What will happen with when I include a vector on an HTML page? Will that vector become a pixel, so I will lose all the all the features by using a vector?
Vectors.
Because vectors are made of lines, points, and curves.
Yes.
I can stretch, I can change the size of the vector without losing any quality, while on a pixel, if I do that, I will be losing quality.
Huh. You know what? I'm not too sure. I think they're probably different, like represented a little bit differently in the background, because pictures are they're kind of static. Whereas vectors probably have some like internal calculations in a way for like the, what's that called? Ratios, right? So it's potentially a slightly different representation in the background, but I'm not sure. That's a really good question. That's a good question to ask ChatGPT.
Yeah, I will do. Thank you.
Thank you so much for asking. How do we know what the different colors are? That's a great question. I'll get to that in just a second. That's what this empty box down here is for. And how does the process of data conversion differ between different programming languages? So that's also a good question. We'll get to the programming languages in just a moment. So there's a little translator sneak peek involved in that process. So, okay. So as long as the computer knows how many pixels to the side and, downwards a picture is made of, then it can break up this entire picture into this string of numbers, kind of going left to right. And when it's remaking the picture for us, when we, try to open a picture file, all it needs to do then is to say, okay, well, I know there's a bunch of zeros and then a 0 and a 1 1 0 0 1 1 0. Like that's how it's going to read this document. But then it knows, okay, but I need to represent that with 8 pixels sideways. So I'm just going to put 8 zeros at the top, and then I'm going to put the 0 1 1 0 0 1 1 0. And I sound like I feel like a robot saying that. But yes, so you need, like, as long as it knows what the conversion parameters are to go from this bunch of zeros and ones to the picture, it can easily do that conversion. Now, getting to that really good question that was in the chat here about colors. So colors are really interesting because if you think about it, it's not just a color like, red and green and blue, yellow and whatever else you have. It's not just these colors that we have, but there's also like, how red is it, right? There's also, differences in like the saturation amounts and the hue of the colors. So they're complex. And the good news is that there is a way to represent them in a similar fashion, pixel by pixel, except there's a lot more information being held for each pixel instead of just a 0 or a 1. So it'll still put all of the pixel information like after each other in the same way, but it's going to hold on to information about how much red is there in this color that should be taking up this box, and how much green is there in this color, and how much blue is there in this color. And the reason why I'm using these colors as the questions is that the computer screen is made up of these three, like, what am I saying here? At least most of us have LED screens these days. Before, I think those like plasma screens. I'm not really sure what the historical transitions from screen types were, but the colors that are coming off of our screens are always in this mix of red, green, and blue. So I see here primary colors. What's funny is that it's actually not primary colors. You'll notice yellow is missing, right? When we think about primary colors, in grade school, we used to learn, it's red, blue, and green, and then you can mix these colors in whatever combination and you can get all the other colors. But the computer screen is actually using red, green, and blue, RGB. Fun fact, the color yellow, what's interesting about it is in our eyes, and this is like a complete off topic, but I love love thinking about how our eyes and senses work. That's a big part of my role outside of this course. But the thing is, in our eyes, we actually have, the way we see color as humans is through these special cells in our eyes called cones. And the only cones that we have are cones that can pick up on red, green, and yellow and blue. And the fun fact here is that the color yellow, like our brain basically makes it up. So that's something to look into. But the reason why the screens only show colors in red, green, and blue is because our eyes only pick up on red, green, and blue as well. So, there's a lot that I think went into, the engineering of computer screens, of course. And yes, so we've got their different color schemes, RGB and CMY. Yes, that is a great point. So RGB is like this basic, way of looking at it. CMY is cyan, magenta, and yellow, I believe. It's a different, basically a different set of these, base colors that, like, when you combine them in a specific way, like you get all of the colors as well. There are some differences in the two color schemes. I don't remember off the top of my head. But yes, there's two main color schemes there. Okay, so given that we need to represent then, if we're trying to put like a color photograph, we need to represent all the information about how much red is there, how much green is there, and how much blue is there in one go. What does it look like? So it looks something like this, where each of these numbers, or each of these colors, so how much red is there, goes from a range of 0 to 256. Okay, and the reason why 256 is the number here is because that's the largest number we can hold in a byte. Okay, so it's still using a byte that we just talked about. It's these strings of 8 numbers. It's using a byte to represent how much red is there. Instead of just 0 and 1, it's saying, well, on a scale from 0 to 256, there is, a certain amount of red. So in this example, there is 142 amount of red. Okay, so that's the, oh, yes. Thank you for that. Yes, it is 0 to 255. Thanks, because the 256 is not actually represented in the in that byte. A total of 256 numbers can be. So if you say on a scale of 0 to 255, we have 152 red. So what that would look like on the computer's end is red would be represented by a byte. And then we have green being represented by its own byte, and blue being represented by its own byte. And when you combine all of these three side by side, the computer then knows that for this pixel here, in the little LEDs that make up that pixel, it's going to turn on red to this strong, and green to this strong, and blue to this strong, and then our eyeballs pick up this mixed color for that pixel, and it's represented like this. Fancy tech going on in the background. Does the color itself have binary too? Depends on the number. Yeah, so each of these here, each of these bits that make it up is binary, and then as we change things, we are getting like as we're picking different numbers, we are getting different ranges within that color. And 0 pure black, 255 pure white, yes, because you're basically like completely saturating that there. Okay. Oh, thank you for that. So apparently CMY, what's K? What color starts with K? Is for printing and RGB is for videos and web. Okay, I did not know that. Thank you. But oh, K is black. Okay. Huh. Would not have guessed. Okay. So the question that was asked earlier about how does the process of data conversion differ between different programming languages is similar to what happens when people speak different languages, human languages, right? If you have someone speaking in English and you have someone who only speaks French, to be able to communicate, you would typically have some kind of translator in between, right? And nowadays we've got really fancy, AI systems coming up where apparently, you can just talk to people. Now we don't need to worry about language barriers very soon. So I think that's really exciting. But usually there's like some kind of translator happening in between. And in our communications with the computers, something very similar is happening as well, but we don't call it a translator. We call it either an interpreter or a compiler, depending on the programming language. So here, yeah. So, and if you know any JavaScript, you'll know that this here is it's just an example showing of a condition. Anyone who has never seen JavaScript before, don't worry about it. We're not going to talk about the code today. We're just talking about this idea of transferring the code that you write into these machine executable actions. So in between, what we have is this compiler or interpreter whose job is to look over the code that you wrote. And when I say look over, it's basically, again, it's reading over from the beginning to the end, but it's reading it in the human, I guess, conversion, right? Like the human conversion. So its job is to basically take the C and turn it into bytes, and take the O and turn it into the bytes, and understand what is being asked here. So that's its job. And then it's going to process that command into, first it's gonna, see what the best way to do this is. There's a bunch of like, I guess, hardware acceleration stuff that goes on in the background. We don't need to get into that. But its job is to look at the code, convert it out, decide what the best way is to, perform that, and then turn these commands into actual executions. So what that would mean is, like, on the hardware side now, it's going to go and check, data that is stored, for example, or it's going to go and perform some actions on the electric component side of things. Okay. So the reason for that, having an interpreter or compiler, and you'll see very soon that every language kind of has its own compiler, whose job is to translate everything into that machine language. But what that helps us with is it allows us as programmers to focus just on the logical side without having to work or worry about the nitty-gritty, what's happening in the background. So as an example, if you like, there are actually computer languages that are lower level, and we're gonna I think I actually have I have a slide on like the level of the language as well. And depending on which language you're working with, you're basically speaking to the computer at a different level. So we have a question here. So we don't have to write binary. Correct. You do not have to write binary. You don't even need to understand binary. Don't think no one writes binary anymore. Correct. So yeah. CPU is the right word, because, that's a lot to keep track of. But the good news is there's these compilers, somebody somewhere created the compilers, and we can all go and, thank their souls for creating compilers. So in terms of the level that you're working with the computer at, no one's actually stopping you from writing binary code. If you wanted to, go on ahead by all means. But there are languages that allow you to interact with the computer at a very low level that isn't necessarily binary, but is still on the level of you're literally instructing the CPU what to do at every stage. And then there's levels where you're not going down to that nitty-gritty detail, but you are saying more clearly, where to go to find data, where to fetch information from and put it somewhere else, for example. It's a little bit more high level, but it's not completely high level. You're still interacting with file systems and what would a good example be? I'm thinking pointers, but that's a headache on its own. It's basically you are trying to provide information to the code or through the code about how memory management should happen. And then the highest level, well, not highest, I would say another level higher than that is when you're saying, I'm going to tell you what I'm trying to do, and I'm going to put the code, and I'm going to use, representations of the data, and it's going to be the computer's job to figure out, where that data is stored and keep track of memory. And then I'd say the highest level is what we're starting to get into nowadays, right? With AI coming up, right? Some of you may have heard of Copilots or GitHub Copilots. There's, GPT right now. It's possible, it's, in the near future that AI is going to be able to write up a lot of the code, which is why, in our first lecture, we kind of started off talking about if AI can code, why learn to code? It's because it can't actually think through the process of, how to solve the problem, but it can spit out the code for you, right? And in that way, in the future, I feel like it'll become the highest level language in a way is going to just be English or, whatever language that these AIs can understand, because then all you really need to do to program the computer is tell it what you want, and then it can spit out the code for you, right? So that's still in the process. I think we're not, there at the level where it's super good yet, but I don't see why it can't happen within the next 5-10 years, right? So there's all these different levels, and I kind of mentioned them. So in high level versus low levels, or actually before I get there, I see here SQL. So SQL is interesting. I think even though SQL is a database handling language, and I do think that you do work with the data, but it's still quite abstracted because you're letting the computer decide, where in the computer's hard drive to store the data. Whereas in the lower level languages, what I meant is that you need to know exactly, at what place in your computer's hard drive is this data actually stored. Whereas in SQL, it's more like, this is data that I want to store, go fetch this data for me. I would still call it quite high level. Okay, so yes, high level languages are the ones we're going to be, learning in this course, and they are typically the most popular ones because nobody likes working. Actually, some people, I will say, do like working on that low level, but most programmers are just trying to get the job done, get, websites up, get businesses running. That's where most of the world lives. And so high level languages like JavaScript are, the most popular. But there are low-level languages. So ASM or assembly is a language that is an example of a language that really interacts with the computer on the level of the processor and on the level of the actual memory addresses. So whoever is programming assembly actually has to know, at what position in this hard drive is the data stored, and so on and so forth. On top of that, another reason there's different languages is because some languages are built for a specific purpose, whereas others are more general purpose. So on the left here, we have some specific purpose kind of languages. So SQL, as was brought up a moment ago, is specific to databases. You cannot use SQL to, like, I don't know, I was going to say do math for you, but you could get around it and make it work. But like typically it's used for storing data, accessing data, making changes to data. That's its job. HTML, you cannot use HTML for logical kind of programming. You can use it to define the structure of a website. CSS, you cannot use that as well. You can't use it for logical operations. It is a styling language. It's meant to be just used for styling. So just like that, there's also more general purpose languages like JavaScript, as mentioned earlier, but also Java, Python. These are languages that, like, if you want to get a job done, that's like just, process a bunch of, I don't know, information and make some kind of logical decision about it. I don't know what a good example would be, but any program where you want to, implement the logical side of things, you will need a programming language that was built to handle a task like that. What is the best language to make a Windows app? Yeah, so for Windows apps, I believe, so if you mean like downloadable ones, I'm pretty sure Java is the most used for that. Python, I'd say Python is more so on the data processing side, and then JavaScript is more so for the web. But all of these languages are built more general purpose though, so you could use one for each other. Here we've got, how about C#, C++, there's also C in all of those. Those are general purpose languages, but they are lower level than Java, Python, and JavaScript, because you do need to do a little bit of memory management yourself. And they have some specializations, I'm not too sure. I do know C is typically used for, or I guess I'm not sure in general, but for anyone who is working with hardware in general, like, any robotics or like microprocessors, you're going to have to write your code in C. And then C#, not too sure, but I remember seeing it in the VR field. So different fields, different tasks. But again, all of these are languages that you can always pick up. So if you learn one, you can always learn another. It's just that they have some detailed differences between them. Python is used for all visual effects used on movies. Really? Oh my God. Okay, I did not know that. That's actually really cool. Have a Windows app maker thing. Interesting. Yeah, so we have an answer to the C# thing. So C# and C++ used for game development with Unity or Unreal Engine. Thank you for that. Yeah, I remember, so one of my, I guess, work placements when I was in school was in building like a VR platform, and for that, like, I had used Unity. So it's probably the same for other game development if you're using that as well. So yeah, thanks for answering that there. All right, another reason why there's many languages is because some are legacy languages and some are more modern. So what I mean by legacy languages, they're kind of like languages that were built, 20, 30 years ago. They might not have some of the functionality that more modern languages do. They're typically also more lower level languages because as things got more advanced, people have started making more and more high level languages. So the thing though about this comparison is that, if you end up working at like a bigger firm, chances are, unfortunately, a lot of the code is written in legacy code. And the reason for that is, because a lot of big companies started 20, 30, 40 years ago, maybe 60. right? And so when they started, they started up the software, they created their, software that people are using, and a lot of them never bothered transitioning out. And so you might have to learn a more lower level language to make changes. But I know that, a lot of them are working on like transitioning from legacy code to more to more modern languages. But then to be able to do that translation as well, like you yourself would have to understand the old code to be able to implement the same features in the new code, right? So there's that. So here I've got Unix, Linux. Yes, and well, Unix is or Linux is an operating system. I'm not too sure, I'd have to fact check, but I think the operating system doesn't actually play too much of a role in terms of the languages that you can run on it. So Linux is akin to like, iOS, no, not iOS, what am I saying here? Like the Mac version, like Windows, Linux, and I'm missing the word. If anyone has it, please feel free to pop that in the chat. The one that okay, perfect, Mac OS, thank you. Yes. So it's an operating system. It just its job is more so to decide on like to be that bridge between like higher level programs and the low level software. Or not software, the hardware, sorry. Okay, and then finally, another reason why there's so many languages. Well, this is less so about why there's so many, but more so, about which one should you learn. So there's a survey that goes out every year. It's I think it's called Stack Overflow Developers Survey. And what they do is look at, for developers that are using Stack Overflow, which is like a forum for developers that pretty much everyone uses. So on there, they ask the users about what language they're using, so on and so forth. And as you can see here, like the most popular ones are right up top. So 63% of all users were working in JavaScript, and 52% were working with HTML, CSS. And then 50% were working with Python, another 50% with SQL. I believe most responders could respond to multiple. So, you would expect these to be bundled together because, all of this is working for web development, right? Python is more so like on the data side, but also could be for general purpose applications as well. So that's all good. You can always, let me actually get the link to that because it's an interesting page to kind of just, 1 second. Stack Overflow Developer Survey. There we go. And I'll just pop that in the chat because, I find it really interesting to just scroll through that and see, how things that you are learning is relevant, to the workforce given what people are doing right now. How are new languages created? So that's a great question. I don't actually know. I believe people like so at the end of the day, even languages are just code, right? They are code that, like, to make a language, it is just a bridge between, like, you're really making that compiler a bridge between what is written to what is understood by the computer for the actions it should take. And so my assumption here, and please look this up, is that, somebody says, I don't like the languages that are out here right now. I think I can find a better way to do things. And then they go and like create that conversion and create the functionalities of the new language. Funny that C++ is very low, although game industry is huge. Yeah, that's pretty interesting. 22% of people in C++. That is true. Alrighty, so this is great. Oh no, my animations are broken. Where do you write code? This is supposed to come up later on. But the question then is, where do you actually write code, right? And the answer is you can write it in any text editor. So you can pull up, I don't know what it looks like on Macs, but on Windows we have like Notepad, right? That's been like the go-to, like just if you need something to write down, like many years ago until now, like it's still around, right? But you can go and you could just write up a piece of code, and you've got code. But what makes the text not just regular text that you're writing, but it makes it, be understood as code, is the file extension. So file extension. And, you may have seen like .txt or doc or docs or whatever it's called for Windows, like Word documents. You might have seen like .png or JPEG for like pictures. So the file extension is what tells the computer when it's looking at the file, how it should be interpreting the zeros and ones that are in that file, that it has stored the file as. So if it's a .txt, it's going to use the conversions of those 0, 1, 1, 0, whatever numbers. It's going to convert those out into letters for our screen, right? And this conversion is done just for our screen. In the background, everything is always going to be in these zeros and ones. It's just right before it shows it to us on the screen, like how should it convert that, right? So, something like a doc or a docs, that's also going to be converted like that. A PNG is going to be converted out into information about the pixels, each of the pixels, so on and so forth. Now, for the file extensions, when you're writing code, it's always going to be based on the language you're writing in. So if you're writing a JavaScript file, you're going to end it with .js. And if you're writing a HTML file, it's going to end in .html, the CSS, and you get the picture. Python is .py, so on and so forth. Depending on the language that you're writing in, you're going to provide a file extension. And what that does is it tells the computer, when you're writing the code and you're saving it, it tells it how it should be understanding that. When you're trying to run the code, it understands, that conversion there, like how it should be understanding this. And when you're trying to open the code file, it understands how to show the information that's in there as well. Okay, but even though you can write it in any text editor and just add the text, the file extension, and you're good to go, what's typically used instead is a specific IDE. So an IDE is what's called an integrated development environment. And what that does for you is it gives you some special features that makes your life as a programmer a lot easier. So the first benefit is that it allows what's called syntax highlighting. So the IDE is a software that some company created. I believe VS Code is by Microsoft. But what it does is when you provide the file extension and you say, okay, we've got the .txt. No, sorry, not .txt. If you've got .js, right? If you've got a JavaScript file, you've said .js. So now the IDE is going to look at that and say, okay, given that I know this is supposed to be a JavaScript file, I'm going to give you some hints to make your life a little bit easier. So you'll notice here, the actual text is the same, but this one's got some pink, it's got some blue, it's got some white, some orange. And the reason for that is because it allows us to see the different parts of the code. And again, this here is just a demo kind of just snippet of code. It's not actually doing something useful, but you can see already that the true and falses are in orange, right? So clearly that tells us something about the way that the text editor here, the IDE, is representing true and false values. We've got all this pink stuff that seems to be everything related to the commands we are giving. So we're saying, if something happens, otherwise do something. Okay, I want you to return something. Again, you don't need to understand what it's doing yet. We'll get to that in the following weeks. But anything related to the commands we are giving are in pink. And then here we've got something in blue. And, it's not very obvious here, but the blue here is giving us a hint about what we are naming something. And then here we've got all this white stuff as well, which is basically, you can see here, it's all brackets for the most part. So that's all in white. And also the semicolon. And those are syntax rules that we need to follow when we're writing the code. And again, we'll get into, the actual understanding of it later. But I want you to just notice that once we use an IDE, we get in one glance, we know what parts are what. On top of that, the IDE also gives us access to a console. So what that means is that we're able to see the outputs of our program and also provide inputs to the program, so on and so forth. We can actually run our programs within the IDE itself. Now, this is with the small caveat. For things like HTML and CSS, typically we need to export or open it within a browser to see it properly. But for programming languages like that are more so on the general purpose logical side, typically you can't just see the output. You have to like run it through the console unless you make a dedicated user interface. Here we've got, does Notepad act as an IDE? So I think in the more recent updated versions, I think it actually does have an IDE feature. I am aware that like some people actually use Notepad as their programming text editor. But typically, I'd say typically when we think IDE, we think Visual Studio, VS Code, IntelliJ, Eclipse, these other programs that are like purpose-built for programming. But like I haven't really explored yet what like benefits Notepad provides in its new iterations. Another cool thing that is provided through IDEs is that you get special tools that allow you to debug easier, and we'll talk about bugs in part 2 of today's lecture. But it allows you to do some debugging and also refactoring of your code. So refactoring basically means if you wrote a bunch of code and you're like, you know, I want to make this a little bit prettier, it can help you do that. And then finally, there's also extra features like linters and code completion, which we'll come back to in the future when we actually start using these IDEs. But the benefits to these is that they, you know, use information about, you know, what you're typing to tell you if you made a mistake or not. So these are just some of the benefits. There's a lot more actually, especially because a lot of these IDEs allow for plugins as well, or extensions that, you know, make your job as a programmer easier, because people in the programming community program tools for programming. So it's a nice ecosystem of people just, you know, finding problems and then like building up a solution, publishing it, and then like other people can benefit from the solution as well. So it's great. If Notepad++ can be a simple idea with color coding, etc. Yeah, awesome. So it has to be the plus plus. Nice. Does it allow you to use any language and the features listed here? I don't have the answer to that. So if anyone does, please go on ahead for that. You used Notepad before. There was no noticeable features for developers. Oh, okay. Interesting. Okay. Sweet. So I noticed, you know, we are at the hour. I was gonna walk through a, you know, download VS Code demo, but I'll do that after the break. Let's go for 5 minutes. And when we come back, you know, we'll dive into just seeing how you can get VS Code set up on your computer and then also talk about bugs. So I'll see you back in about 5. Okay, as you're getting back, please let me know if you could pop like a thumbs up reaction, just to let me know you're here. That would be awesome. Or pop something in the chat. Sweet. Nice. Alrighty, thank you guys. Thank you. Okay, all right, so we are ready to go. We'll take 5 more minutes. Okay, no worries. All right, so I think, okay. I think I'll finish up with the debugging presentation, and then I'll come back to the downloading and installing VS Code side, because then we can, like, if anyone's having trouble with that download, we can like help you out right after during lab. So I will continue here with the presentation and then come back for the download. Yes, Nanshel?
Can you hear me?
Yes.
Okay. So to debug the errors of a code, we will be using Visual Studio.
Yeah, so we'll use VS Code. Visual Studio it's the same, I think, overarching company, but it's got a lot more like features and can be a little overwhelming. So we'll be using VS Code or Visual Studio Code. And we'll be using that for, yeah, writing your code, debugging it, running it, testing it, all of it. We'll do it all on the IDE.
So all the HTML will be under one place.
Yes, all of the languages just in that one software.
But not the files, right? Like images, sounds, movies, no, huh?
Correct. Yeah. So the cool thing about VS Code is that it allows you to see the folder that you're working in. And then from that folder, you can open up, let's say, your code file and work with that. But then you can also put the pictures that you want, you can put those in the same folder so that you can refer to like the pictures within your code, but not have to worry about like that. It just looks at your folder and allows you to do it that way.
Oh, that's nice. And it will show also all the bugs, the errors, the messages.
So yes, it will show you error messages, but it won't necessarily show you all the bugs, because a lot of bugs are what we call silent bugs. So you'll have to like find the bugs, but if it does run into an error, it will show you an error message. Yes.
Oh, nice. Okay.
Sweet.
And are you gonna send us a link to download, or
Yes.
can I just Google search and create an account on my own?
Yeah, so you can find it very easily, Google searching, or you can, someone has posted in the chat here, thank you. I also included a link within Canvas under like resources. There's like a link that takes you to the website. I believe you don't need to, oh, I use this one. I don't know if it's the one we're using.
I don't have to be under.
Yes, this is the one.
Like in Slack, right?
Perfect. Sorry?
I don't have to be under coding colors like in Slack. No, right?
Not in Slack, in Canvas, where you are submitting assignments.
No, I mean for the Visual Studio, I don't have to be under coding colors like the Slack one. You know what I mean? That I have to find you on Slack.
Oh, no. So the link that Mahom posted in the chat here, that will work.
Okay, thank you.
Yeah, that goes to the right place. So we have a question here. Do we have to use VS Code for IDE? The answer is no, you don't. It's just the one that we're going to be showing in the examples, like when we're screen sharing. But you don't have to. Like if you have been using an IDE in the past and you want to use that one, feel free to go ahead. And I think I paused my screen share by mistake. Okay. Okay. So let's talk about bugs first. And then when we are done with that, we can come back and I'll show you like the actual installation process as well. So bugs, we've all been angry at software not working, right? We've all been this guy. And we've also all gotten advice like this, saying, you just turn it on and turn it off and turn it back on again and it'll work. But the question for us as developers is not just how do we make it work, right? Look at the size of the monitor. True. We've come a long way, right? But for us as developers, you can imagine, your job is not to use the software, right? Your job is really, did he blow on it? Love it. Yep. Top troubleshooting methods. Our job as developers is not like on the consumer end, right? It is in trying to make sure that you write programs that don't crash, or you write programs that always run. And of course, we have issues that can happen on the hardware side, like your monitors freezing, or that's not really, I feel like it's still software because it's probably your operating system crashing. We've all seen, the blue screen of death on your computer, or if you haven't, you are blessed. But it's typically a software issue, but there can be hardware issues as well. Like if you're you spilled water on your computer, knock on wood, that does not happen to anyone. But you can mess up your hardware, but a lot of the times you have like software issues that are causing problems. And so if you are a developer, your job is going to be, or your goal is going to be to make sure when you write programs, they don't crash and they don't freeze and they don't, I was gonna say they don't, if you're making like a banking app, they don't, take one person's money when it wasn't supposed to, right? Like all of these little like stuff that need to be properly working. And so we need to make sure that our code is bug free. Now, before we get to what are bugs in our context, let's talk a little bit about how much they cost, right? So bugs, if a software is released with bugs in it, well, you're gonna have angry customers. It might cost, issues with like legal issues, and it might cost like, loss of credibility. It might cause just, you mistakenly sell all your products for free. Like it might cost you a lot. And there are some famous, historically extremely expensive bugs that I wanted to just showcase here because, I myself, I can't even imagine this kind of money, and it got lost to a bug. So there's a satellite by NASA. NASA made mistakes, they're like, but they had a satellite and it was supposed to land on Mars, and they had an issue on the software side. It was something about like data conversions being wrong or something being off like that. And the satellite or the orbiter entered orbit too close, burned up in the atmosphere and just kaput. It was supposed to just go and stay in orbit, but bye-bye expensive satellite. It cost NASA $193 million. Another really big famous one was the Knight Capital Group. So this was in the stock exchange. So it was a company that was trying to use algorithms to buy and sell. So with with day traders, their goal is to buy things low and then sell them high, right? Typically in the same day. So what they did was they had an algorithm, they had a software whose job it was to do that. But then there was a bug in it. It started to just buy up a whole bunch of stuff that wasn't, good deals. I'm not sure what the details exactly are, but in this fiasco, they ended up losing $440 million, and it almost bankrupted them on the spot. Whoever created that bug, I pray for their soul. And then we have another really, really expensive one, which is called or referred to as Y2K. And what happened here was, look at that number, 100 billion, right? That's not million, that's billion. Like, what kind of money? But the reason why this is called, it's like one of the worst bugs in all of history is because, how when we use dates, right, on our programs, devices, scheduling, pretty much everything, there's like dates involved, right? Now, typically when you're putting in a date, you put in the two digits for your like the, what's it called, the century that you're in, right? Now, what happened was, as when the 1990s were finishing up and they were getting into the 2000s, people realized that when there was a rollover, all of these, yeah, all of these dates are going to be read as, 1900 and not the year 2000 because of that rollover of the century. And so what had to happen then is every single software company had to go and catch that bug in their code, and getting people to do that, the time that was spent, because developers are not cheap. Y'all are going to be, expensive people to hire and to go through the through the software and fix this kind of bug, right? Overall, it cost 100, the best estimate is close to $100 billion just to go and fix that across all the software companies through that. I have lived through it. Wow. Like that is, yep. Whoops. So it's rough, right? These little things that we don't really think about can cause massive issues when deployed without being caught before deployment. So let's start off with what is a bug, right? And when I hate bugs, so it's always like, it's like these physical bugs. And the thing is, when we talk about software, as some of you mentioned earlier, it's meant to have it's like a catch-all term for errors, mistakes, issues in the code, issues in the connections, things like that. A lot of people may have heard about Grace Hopper. So she was a computer programmer from I don't remember which year, but a long time ago. And her bug was, it's a pretty famous bug. And the reason for that is because in her years, and I'm not sure exactly which year this was, but she was trying to find out why the system was not working. Turns out she found a hardware problem, not a software one. And the hardware problem was that there was a moth kind of in the hardware, stopping things from working. And so the reason why it's famous is because in her notes, she actually stuck the bug into her notebook and wrote first actual case of bug being found. And it's just been propagated through history in that way, because people were referring to these, issues with software or hardware as bugs for a while before that. And it's a nice story around actually finding a real bug there. You like how she taped it, yeah. But typically when we it's taped, yeah, it's stuck into her notebook. So in the software world, typically when you encounter a bug, that's not what you're going to see. You're not going to actually find an actual bug there. What you're actually going to experience is something more like this. Again, this is the blue screen of the blue screen. We've got an unknown error. We've got this here is what we're going to be working with because we are developers, but these other ones are on the consumer side, for people who are using your programs. If there are bugs in them, these are kind of things that they can see. So the one I love is this one. But as you can see here, there's different representations of errors depending on what kind of error happened, right? So in this case, we've got, and we'll come back to these types in a moment, but here we've got, an actual program that crashed at some point, and this was the error report. I believe this kind of looks like, okay, no, it's something called Fabricam, not sure what that is. But it crashed, and then it says an unknown error occurred. Here it looks like it says, an error occurred while creating an error report, but it doesn't seem to have crashed their whole system. I could be wrong, but they had an internal error while trying to perform a task. Here we've got an output that you're going to get very familiar with reading and solving problems around. This one here is a an output similar to what we would see in VS Code if there is an error. So here there is some code that was written. There is a syntax error, which is basically an error in the way that the code was typed. And so it's telling us what kind of error it was, and it's telling us what happened. So we're going to get very comfortable with errors in this sense, less so in these other ones, because we are the developers. We're going to be working with the work itself. Fabricam is a fictional Microsoft company. Oh, interesting. Okay. Fun facts. And then down here, we've got the answer to 1 + 1 is 3, which is an error as well. It's still a bug, but it's not one that's like it's not crashing the system, but it is wrong. So it is still an error and it's still considered a bug. All right. So the next question then is, where do bugs come from? And can I have some guesses? Mother Nature. So we've got poor code, Mother Nature. Yeah, poorly written code is good. Any other sources of bugs? It would be nice if the syntax error gives you the paragraph, where to find the bug. That's a really good point. For the most part, yes, we will be getting information about where the code crashed at. And then we can go in there and kind of find that line of code and fix it that way. So that's a really good point, and it does. Alrighty, so there's actually a lot of sources when it comes to these bugs. The first is human error, and this is what's kind of alluded to here with poor code, and I should probably say the first is Mother Nature if we're talking about actual bugs. But here with code bugs, I think the most common source is human error because, as humans, we make typos, right? We have typos, we have, maybe we thought through a problem incorrectly and we put in the wrong code to begin with. Here we've got hacking in the chat. I wouldn't classify hacking as part of the bugs. I feel like typically when there's hacking involved, the code itself isn't think about this. I think the code base that's actually being run doesn't necessarily change. So it's more so like, what we have here as a suggestion, it's more so vulnerabilities in the code that exist versus like it's a type of bug more so is what I would classify it as versus like a reason why. Right. Okay, yeah. Thank you, Tasneem. Yeah, they can. That is true. Hackers can create bugs, so yes. Sweet. Okay, so human errors. Human errors can be classified into 2 parts. So the first is syntax errors. So syntax errors are places where the code is there and it could be correct code. It's just that you misspelt it or you mistyped it in some way. So, in English, if you misspell something, that is akin to in software if you have a syntax error. You are trying to do something, but the computer does register it because you typed something wrong. And the other is a logical error. And this is the kind where if you had created a piece of code that is, providing the wrong output given the conditions that it was given. All right, so in like a everyday example, it would be if you, did your math wrong or you like made the wrong conclusion given the facts. If you divide a number by 0, yeah. All right, so human error is a big, place where these errors come from or these bugs come from. Another is connection failures. So we've all come across these kind of pages before where either it says error 500 and, a couple lectures ago, you learned about these different codes. So 500 is if the server there's something wrong with it, the server's down, and it wasn't able to respond to your request, then you get a 500 error. And there's also 404 errors. Now these are, more so on, like, even though these pictures are taken like from the web side, as like the users kind of using it, on the programmer, as you're developing things, there is a lot of like, especially when we get to eventually like connecting, let's say, your front end to your back end, they could be hosted on different servers, and you might run into these kind of errors even as a programmer, like while you are trying to build your software. So it's very important to make sure that like the whole process is working properly. All of the pieces that need to be connected to make your program work are working. Will you give an example of what a logical error looks like in the technical aspect? Yeah, so I suppose an example could be like, if you were supposed to have a condition, let me see here. If you are, can't think of one off the top of my head, but it's like if you are trying, like, without using like if statements, but if you have like let's say you wanted to say, if the person who is trying to log in or sign up is over the age of 18, then I'm going to, or let's say 13 for like, social media, right? Like, if they're over 13, then I'm going to let them make an account. But instead of 13 there, or instead of over 13, you mistakenly put in under 13. And then that would be like a logical error, because the code is saying if you are under 13, then I'm going to let you make an account. And so in that way, it's not a syntax error, because the code is valid. You're saying if the person's under 13, allow them to make an account. It's valid code. So it's not like a spelling error. But what the code is trying to do is wrong when it comes to like what you were trying to do. What you were trying to do is say only people over 13 should be able to make an account. So that would be like an example of a logical error in there. Are connection failures more so symptoms of bugs, or is that where bugs root from? So the connection failure, so the pages that we're seeing, yeah, these would be the symptoms of the bugs, but the bug there is like the actual connection being a problem, like having unwanted results due to programming language. Oh yeah, thanks, Yaman. For everyone here, also, just by the way, Yaman Sanabar, who is somewhere in here, if you want to like pop off mic for a second there, Yaman, and just sort of say hi to everyone. He's going to be one of your instructors too.
Yes, sure. Thank you, Hafsa. Hi, everyone. I'm also one of the instructors, and I'm happy to be here, actually. And I'm looking at the chat, and it's interesting to see like people are, enthusiastic to learn. And happy to meet you all. Hey.
Thanks, Yaman. And yeah, like, I mean, I love this interaction. Like, you guys are, it's very good. It makes the lectures very much more interesting for us as well. Alrighty, so what else do we have? We've got incorrect specifications. So I put little pictures of cookies because, if anyone has tried to make cookies, like if you mess up one little ingredient, you get a very different cookie, right? So the reason why this example came to mind is because if you, let's say you wanted to, build a piece of software, and if you get it wrong, like you thought that, let's say we go back to that age example. You thought that, anyone over 13 should be able to access this, this social media, but then, or maybe not social media, let's say it's a game, right? And then after a while, you realize that, well, actually, I was going to say maybe 8-year-olds can play the game too. Like that would be like a very small kind of issue. But basically, if you thought that your cookies always turn out hard, but like if you thought that you needed your software to perform a certain set of tasks, because either the user base is a certain like a certain type, or the problem that you're trying to handle fits within a certain scope, but you got that scoping incorrectly, then what you would have is you have decided, okay, I'm going to build a piece of software for this subset of, people, or for this small scope of the problem, but then you might be handling the wrong cases. So if I don't really have like a tech example, but in the cookie example, if you think you want to make a cookie, and then you're like, okay, I think that I need 3 eggs for my cookies, but then you got that piece wrong, like you're gonna end up with a not so good cookie, right? And it's similar in the tech side, because earlier today you all learned about like the UX side of design, right? Like what is the user actually needing? What do they want from the software? How are they using the software? If you get answers to those questions wrong, you're probably going to be building a piece of software that like isn't serving the needs of your customers, or isn't serving the needs of your end users who are supposed to be coming and interacting with your program. So specifications, getting that right is really important. And it depends on what kind of job you end up doing, or if you start your own company, like it really depends on like whether your job as a developer is going to be creating those set of specifications or not. But a lot of the times it's good to have an idea of like, how are these specs created, and why are these specs chosen? So if you have that incorrect, you might have bugs there. Dependency issues. So a lot of software depends on other software, and some of these softwares are live, like they're hosted and online and things, and others are more low level. They're more like you wrote code that is going to interact with someone else's code that you borrowed through what's called a library, and we're going to be using libraries a lot. So most of the time when you're coding, you're not starting everything from scratch. There's a lot of things that like are repetitive that you can just borrow from other people's work and say, okay, well, there's a library out there, which means that somebody somewhere found a problem, created a solution, published it so that other people can use it, right? So if there's something wrong with the library, or the person who initially published it changed some things there, and now your code isn't working properly with the library, these kind of dependencies can cause issues. And the reason why I chose this little GIF here is because, in a relay race, you've got, one person whose job is to pass things on to another person. And if there's something wrong in that pass on, you're going to get issues. And so in the programming world, if your code depends on other code and there's a problem with that dependency connection, you could end up with a bug there as well. Another cause is user behavior that you did not predict. So if you are trying to create your program, a large part of it is testing it, and we'll get to testing in a moment, but a large part of your job is to make sure that you wrote the program good, but then also that you tested that it still works properly within multiple use cases. Now, if you wrote a piece, like if you wrote a program and then you're expecting users to always use it in the same way, as developers, we should always come in with this mindset of users are most likely going to do something different from what we expect them to do. They're going to click on something we didn't expect them to click. They're going to put in, numbers where they were only supposed to put letters. They're going to, put an exclamation mark when, in a phone number form. Like, we need to expect these kind of cases. We cannot trust that the users are always going to be putting in things perfectly. And so user behavior is like, if we don't account for potential other user behaviors, we're gonna run into like programs crashing and errors coming up. Okay, so that's another reason why programs can have trouble. And then the question then is, how do you debug your program? So debugging is the terminology that's used for the process of finding and fixing bugs in your program. So typically it's an ongoing process. You're always going to be debugging your code. I don't know if there's any such thing as like perfect code, because even if your code is good and running, if it depends on any other code, like if that code changes, you have to come back and fix things. So there's always, it's like an iterative process, and especially if you're working on like a bigger application, definitely. All right, so typically when you are trying to debug something, you're going to follow this sort of these steps where first off, you need to make sure you understand why that error is happening. So reproducing the error is a really good idea because that will give you a sense of like how that error, like what actions led up to that error occurring. Once you get there, you can isolate the problem. So, the question earlier about like finding out which line of code it crashed on is a good example of that, because then, okay, my program was running, it ran through all of these lines of code, and then it got to, line 157, and then it crashed. And at that point, you kind of look at that and say, okay, there's something wrong then on line 157 that is causing this program to crash. Okay. So that's very similar to finding the bug. So, on line 157, you can look at that then and say, okay, what about this line could be going wrong in this use case? So you find out what could be wrong, and then you apply the fix. Okay. So that's very similar to this little cycle here where you define the problem, you analyze, verify the causes of that problem, develop, the fix, the plan for fixing it. And then, once you have fixed it, make sure that, you try doing those steps again and make sure it doesn't crash, because it could be something else other than what you just fixed, right? Now, one small thing to know is that, you can test your code, you can test it out, you can try all these different, potential things that your code might be running up against. But all that gives you a guarantee of is that your code works for the cases that you have tested. There can always be cases which you had not thought of that your code could crash on. So that's unfortunate, but it is just the way that, I guess the way that it works. We can only know that it's working for the cases that we have tested. There's no way to just be like, does this work for all cases? Okay, so let's think about debugging in everyday life, right? So, if you've lost your keys, and just instead of just here, where, if you're looking for your keys, typically, like, what would you do? What are the steps you would take to find your keys? And while you guys are thinking about that and popping into the chat, I'm just going to read this little question here. When you say reproduce error, do you mean in coding sense? How do you do that considering it already exists, and that sometimes you don't find the bug easily even if you were to crash? Right, so that's a really good question. So it depends on the kind of bug that we're dealing with. Sometimes the crash report or the error message that you get is good enough. You don't need to go back and try to reproduce the error again. But sometimes, maybe you didn't come across the bug. Maybe, a user emails and says, hey, I was using this and, it took $5 extra than it should have. I was trying to buy your product and it took $5 extra. I'm angry. I'm going to tell everyone that this is a scam, right? That kind of thing. Like if you get a bug that maybe you haven't, you don't know what's causing that bug yet, you might have to reproduce that error to try find out where that bug is. But yeah.
But I guess my question is how would you reproduce the error if you don't really know, how, I'm not really sure how to word the question, but how would you reproduce the error if you don't know exactly what the problem is?
You would know there's a problem because you ran into it in some way. And then you'd kind of backtrack and find out what steps you can do to make that same error happen. Does that help? In the example of a user kind of saying, I was buying this product, I don't know, I have this little stuffed cat here, but I was buying a product and it was supposed to cost $10 and it cost me 15, and all of that. Then you would get that's a user reporting an error in your software. If you have something like this, as an example, then what you could do is say, okay, great. That means I need to go onto my website or onto my program and try to buy that same product and see, at what point, you can monitor also while you are running that or following those steps. You can monitor on the on your end, like on the developer's end, you can monitor for changes. So there is also that's kind of a more high level example, but when you are writing your code, let's say you are writing your code and then you're trying to run it and it's not running right. There's developer tools within your IDE that you can use to step through the problem. And we'll work through that in a future lecture after we actually start, getting your hands on into the code. But you can step through your code line by line and see how your program is reacting on every line to make sure that it's reacting the way that it was intended to.
Okay, thank you.
Alrighty, I hope that helped. Okay, so for finding your keys, so we've got one answer here. Look at common places that you usually place them. Okay, and then when I can't find my keys, I jump 3 times. That's funny. Yeah, so we typically have a method in our mind for how to deal with problems that we run into on a daily basis, right? If you can't find your keys, you can go ahead, look at those places that you might have placed them. Or you can say, okay, what was I wearing, the last time I did have my keys? And then you can go and look in those pieces of clothing for your keys. Or you can say, who was I with when I last had them? Maybe I gave it to that person. We have these kind of steps. If we really break it down, we're actually using these kind of step-by-step problem solving methods to find out where the keys are, or to find the core of that problem. Right, and then we can solve it, matching songs. So very similarly, we have in the code, right? It's just meant to be an analogy. We do debug things every day, right? If your your coffee maker isn't working, you might go through a process of finding out. Actually, don't know how you would fix a coffee maker, but if something isn't working that you're interacting with in on a daily basis, a jar isn't opening, you might go through a process. You might try to maybe your hands are not maybe your hands are wet, and then you would go and dry your hands and try to open the can, not the can, don't open cans with your hand, bottle, right? So if you're running into any problem trying to perform a task, you can go ahead and try to solve that problem using steps. And so part of your lab exercise today is going to be trying to just think about some kinds of issues that you run into just on a daily basis. And we don't need to get too deep, just actions that you were trying to take that didn't work the way you wanted it to, and then how you went about solving them. So we'll get to that for the lab. For error messages, I didn't want to get too detailed in here because we have not started looking at the code yet, but when we do, there's different kinds of error messages that you receive in your IDE, like VS Code. So one is an error report. It is the program has crashed. This is what happened. This line is the problem. There's also warnings that are provided sometimes, which is, it's not crashing your program, but there is something wrong that is typically something that the program can pick up on, or the IDE can pick up on. And then sometimes you also get information just coming back to you, which is not a warning. It's not an error. It's just some information. Typically, every error comes with an error code, which makes it really easy to look up that error. So if you got a specific error code, you can look it up, Stack Overflow, documentation. Nowadays, GPT, find out what does this error code mean, right? To find out more about how you can go ahead and solve it. And then the biggest part, I've kind of mentioned developers tools. Again, we'll do a formal walkthrough of the debugging tools once we start actually coding. but the debugging tools are going to be your best friend because it lets you take your code as it is and walk through it step by step to find out what's working and what isn't. Right, thank you for that, Abdulhadi. So a really good warning that comes up a lot is you have declared a variable, but you have not used it. So again, for those who don't know what a variable is, don't worry about it. Are all error codes the same throughout all languages? That is a good question. I don't think so, but I don't know either. I feel like they would be different error codes, but not sure. All right, so let's talk a little bit about testing. I know we're getting to the end of class here today to give you a sense of, what goes on in the development process. So we talked about, okay, great, we've got these bugs that we've got to be careful of. We have ways to debug our products, but how do we make sure that when we launch our product or launch our website, that it is as bug-free as possible? And to do that, we have what's called testing. So there's 3 layers of testing, and I know if we get technical, there are more. There are potentially more layers, but the 3 that I want to give you the picture of today are what's called unit testing, integration testing, and system testing. So unit testing is the process of going down to the basics. What is the smallest unit of this code that I can test? So in the, there's a car picture here because I wanted to use an analogy of a car to explain the difference between these kinds of testings. So for unit testing, you would go down to all the way down to the base. So let's say you want to check the tires, make sure the tires are working, or the wheels in general. You want to check the seatbelts, make sure those are working. You want to check the engine, but not the whole engine. You want to check the starter, make sure that's working. So those are units within the system that have a job to do, and you want to make sure that it's doing its job so that if you do run into an issue, it's not a problem with that little piece. It's something else. So, lights, the whatever else there is, the doors. I know cars are so much more technical than that, but I don't know much about cars. So it's the process of going down to the most basic thing. Okay, and then we've got integration testing, which is how do you take all of these little things in your code? For example, you might have different functions or different processes that are supposed to be running and they're working fine on their own, but how do we make sure that they're working well together, right? So you might look at a slightly bigger part of the system to say, okay, in the example of the engine, you might look at different parts that make up the engine. I don't know what all the parts are, but if you've ever popped the hood of a car, there's a lot in there, right? And you might want to say, okay, how do I make sure that everything in here is working together so that, each piece is working well on its own, unit testing. When I put them together, I get an engine that is working well, all at once. And then on the system testing side, you are going to take a step even further and say, okay, given that this part of the program is working well, how is it working well? How is it working with all of the other parts in my program? So in the car example, it would be the engine, but then you'll need to make sure that the engine is working well with the wheels to turn the wheels, and it's working well with the door locks to make sure that they lock when you hit a certain speed and all of that stuff, right? So it's more of a system level test. You want to test the entire thing at once. So in the, okay, I thought I had an example of if we were thinking about an online store like Amazon, for example, some of these differences would be, in the unit testing side, you might test just a small feature, I don't know, logging in, but not even the whole login, a small set of the process of once you get someone's login information, you want to just, I feel like login's a little bit interesting. Maybe not a good example, but you one small thing that you need to test would be a unit test. And then you could say, okay, well, how do I make sure that what happens after this piece is run, or how does the login piece work with, information about their profile? I feel like I'm giving not such a great example because there's bigger stuff happening in the back there, but the idea is like when you have small bits and then you want to like test it with other things, and then like a system level test would be something like, how do I make sure that when a user is logged in and they put something in their cart and then they log out and then they come back in, they still have the thing in their cart and then they can check out and then they could come back and see their past orders. Like that's a lot of different things working together, and that would be more of a system test. And we'll talk, you know, when we get to the actual programming part, we'll talk about how you actually write these tests. You know, hint, testing is typically also part of what you can code up, especially in the unit and integration tests. Most of it is also part of your code as well. Okay, and when you are testing, you also need to consider edge cases. So what that means is when you are testing, you don't need to test, you know, if someone puts like, let's say you're trying to test a subtraction machine and you're like, okay, if someone puts a 5 and someone puts a 2, like what happens? You get a 3, and someone puts a 10 and someone puts a like 3, you get a 7. Like you don't need to test every single number in the world. What you do need to test are edge cases. You need to test, does it work for regular numbers? If someone puts a 10 and a 3, do I get a 7? Yes. And typically you'll put like 2 to 5 like tests of like regular values. And then you need to ask yourself questions about at what point does this system like break, or at what point do I need to worry about? Like if someone puts a 0 up front and then they want to subtract a 5, does that work fine in my system? Yes. Does that work well in my system? And so, yeah, so Ezra's asking about, if you're testing, if a user is signing in, you need to make sure that the user information exists in the database. Yes, but like with a small caveat there, because so testing, like checking if something exists in the database, I realized was not a great example, because that process of like querying the database to check if the user exists, like that process there makes it not a unit test anymore. It is integration. You are like testing if these pieces are working together. So it's more so like, let's say more so in the user form itself, like, you know, if you were expecting an email to be coming in, like, was that actually an email? Like, did you provide the user information if they didn't put an email, if they put like numbers instead? I think that would be a better example of like a unit test there. Yes. Testing the fuel system could be like a unit test in a vehicle. I suppose so. I'm not sure what goes into like the fuel system, but if it's something just like, you know, if like, I know that I have enough gas, is that what I'm saying? You know, is that what I'm showing on the dashboard for the car, right? All right, so integration testing would take more combinations. Yeah, integration testing is typically when, you have a part of your program, collaborating with another part of your program as well. So it's like working together to perform a task. So I don't remember what I put on this slide. Oh, okay, so it's continuing that car example. If you have a car that's working, you have your system running, but you want to make sure that it works in all weather conditions, right? So that would be, for example, an edge case. Sure, you might have tested it on a bright sunny day and it's perfectly fine, but you have to make sure that, you know, it could be a rainy day one day and your car still works. Yeah, so for the question about how unit testing the login or sign up process, I think it's a little bit, so I realized when I mentioned login that like logging in is a more complex test. So for the unit tests, we would test like a small part of the login process, like, you know, is the user information being captured like properly? Are we making sure that the values that are coming in are valid values? Whereas like, if you're trying to go and check in the database if the person exists, like that is beyond the scope of a unit test. On the internal side, a unit test for that would be if I assume that I know the person, like I'm not going to go and perform the actual database test, but I'm going to say I'm going to test if I know what the person's, if I know that the person is in the database already, if I just assume I know that, do I accept their login request? That would be like a unit test. But I think it's a little difficult to talk about unit tests, especially like system and integration tests. I think it is easier to talk about at a high level without looking at the code itself. But unit testing, you're really testing like your code for a small feature. And you're really just saying, did I code this properly? If I gave it a 5, did it register it as a 5? Or did it like react the correct way that it should have when I gave it these values? I think we'll come back and revisit testing when we like look at the code, like the code side of like debugging, and we can walk through like the debugging tools then as well. I think I'm not sure how much. I'm like, okay, let me see here. I think, oh, JK. Okay, so I'll just walk us through edge cases here, because I do see that we are getting to the end of the lecture part. I don't want to like keep stretch it too far into the lab time to give you enough time to complete the labs. But in the example of the car, so with the edge cases, when you are testing your programs, what you are testing for is to make sure that it doesn't crash when something unexpected happens. And so you think about, what are some examples of things that are like things that could happen that I don't want my program to crash for, that I want to kind of allow or to provide a response for without crashing the program. And so like some edge cases, in the car analogy would be like bad weather or a rocky terrain that, maybe the car was never tested on, but it is possible that someone buys a car and then they're like, okay, I'm just going to take this everywhere because it's a car, right? It can handle, but maybe not, right? We've also got, we've also got, what if someone drives it for a really long time in really hot weather in a desert? Does it still work? What if someone, is unable to reach the pedals? Do we have systems in place to allow them to adjust their seating so that they can still use the car, right? These are, examples in the car scenario of like edge cases that, if you're just looking at a car, we don't really think about, but it is very possible that the car would have to face these kind of scenarios. So taking that analogy into like the programming world, if you, created your software to be able to subtract numbers and someone puts in a negative number as the second number, right? So instead of like having 10 minus 5, now as the input for the second number, the person has put -5. Does your computer or does your program work fine for that? Does it consider that as an addition or not? Like that would be, a very simple example of thinking of edge cases, thinking of ways that user input might come in, or 10 minus and then someone put a B instead of a number. Like what happens then? Does your program just crash, or does it give them a message saying, hey, please put a number, right? So that would be small examples there. I see here, really confusing to differ the integration unit testing. Yes, I agree. So for that, unit testing, we'll get to that again, because unit testing is like a whole, every time you write a piece of code, you need to write a unit test for that, for the most part, and we'll come back to it in the future. For now, just think about it as like the unit testing is you are testing the most basic code snippet that you wrote. Integration testing is higher level than that. You're trying to make sure that this this snippet that you wrote works well with all the other code in your system. Okay. We'll come back to it when we start actually looking at code, because then it'll be a lot more clear then. Okay, so I think, so I did have this, Amazon picture, but I realized that talking about big, actually running websites is, I think, beyond the scope of what we are trying to achieve here, which is help you understand that there's different levels of testing. Because I feel like, especially on the unit testing side, it would be really hard to talk about what the programmers had to unit test here, but it's the most like the code itself that you are testing. So I'm just gonna pause it there and say, we are in today's lecture, as like a recap of what we covered, we looked at, what it means to test your code, which really means to like make sure that it works for the scenarios that you think are going to happen when your code goes out into the world. And we also looked at, what bugs are and how you debug a process when you come across one. And earlier in the first part, we looked at how computers understand what you're saying when you actually wrote the code. Okay, so let's stop it there. And again, all of these concepts we are going to come back to. It's not like this is it. We're setting the stage for the things that you will need to learn as developers. And again, like the quality assurance field is like an entire subfield of its own. Just like a lot of the topics that you have learned today, they have their own like subfields. So it's a really big concept that as we see more and more, we'll understand better and better. So let's take a break now before we dive into lab. Typically, it's like a 10-minute break. So let's take that 10-minute break. If you are interested in getting started on the lab already, I'll put up the slide, but you are, fully entitled to taking that 10-minute break before you come back to work on the labs. Okay, so for the labs today, what you're going to do is, think about some of the small problems that you might have run into while just going about your day, and what you did, like the process that you took to debug them. So in a way, like for this, it doesn't need to be too technical. It's just, we want you to get thinking about the process that you are taking already for problem solving, right? Because if you understand the problem solving process, it's going to be a lot easier when we're looking at code to think about problem solving for the code. Okay, so it's just, make a small list. I know I didn't put a number there, but let's say come up with five examples of things that you were trying to do, it didn't quite work, and then what you did to fix it. For number 2, I think I'm gonna scratch that out and I'll put that I'll cross that out on Canvas as well. I'll move this to another day this week. Possibly I'll look into it, but another day this week, because I do want to run you guys through that download and setup demo before we actually go off and do this. So we'll do that later on. This one's going to be fun. Where earlier today you thought about the requirements or the user stories for your hobby app, and we want you to try and sketch out, a design for that application or for that website. What do you think it would look like? Where would the buttons go? Do you need a navigation bar? The kind of things that you learned, what color scheme would you use? What fonts do you like? So think about those and just draw, you can draw it by hand as long as you can submit a picture at the end. So you'll just submit a list of challenges you faced, how you solved them, and then a picture of your website design. All right, so we'll see you back in about 10 minutes.